Hello viewers, welcome to finite element analysis. In this video, we are going to see how to form a simple one-dimensional heat transfer element problem for thermal rod. Yes, simplest one-dimensional element for heat transfer problem is a thermal rod as shown in the figure. The unknown variable at each of the two nodes is temperature Ti and Tj. The diagram is show the simple element have two nodal points. The node 1 temperature 1 is Ti, then node 2 is Tj, then heat flow rate is Qi, nodal point 1, nodal point 2 Qj. The Fourier's law states that the heat flow rate Q through the rod is proportional to the temperature gradient dt divided by dx in the direction of conduction, that is Q equal to minus Ka dt divided by dx, where Q is the heat flow rate, K is the thermal conductivity and A is the conducting cross-sectional area. From that, for the finite element of length L, shown in the figure, if the linear variation of the temperature is assumed along the length of the rod, then Q equal to, as per the Fourier's law, minus Ka dt divided by dx. So ddt the temperature variation difference, Tj minus Ti, as per the nodal point two nodes. The figure indicate the element, the E will be indicate notation is element, I and J will be indicate the nodal point 1 and 2. So apply the Fourier states law, temperature variation, then dx is xj minus xi equal to L. So from that we form a equation, temperature difference and length along the length of the rod. Then for calculating of the heat flow from nodal point I, in other words Qi equal to minus Ka divided by L, apply from the Fourier's heat law. So Tj minus Ti. Similarly, it is clear that for calculation of the heat flow from node J, Qj minus Ka divided by L, Ti minus Tj as per the shape function calculation. The above the two equation at nodal point 1 J, nodal point 2 J, these two equation can be stored most conveniently in the matrix form, in vector form Qi Qj, Ka divided by L, 1 minus 1 minus 1, 1 is stiffness matrix, then vector of temperature distribution is Ti Tj. The equation is the element equilibrium equation of the one-dimensional rod. This is the analogous to equation with the following substitutions. This the equation indicates the structural element one-dimensional problem, system of FEA equation, force vector F, then stiffness matrix K, then Ui and Uj will be indicate the displacement vector at nodal point 1 and 2. So F will, it is a replace that see the difference between that thermal problem and structural problem. The force vector will be replaced by the heat flow. Then stiffness matrix is structural problem involved area of cross section and Young's modulus, the material property divided by the length of the element. In thermal problem, thermal based on the thermal conductivity, cross sectional area of the thermal element. When more than one element is considered, the element stiffness matrix are assembled to give the global stiffness matrix G. In the same way as the stiffness matrix of the pin jointed bar element were assembled, as the result the system equation is derived and the form is indicated in the slide. Thank you for watching my video. I hope this is useful for finite element fundamental concept, how to form a element system of FEA equation for one-dimensional thermal rod problem.